Hi friends, welcome to AMG World. Here I am with a new topic which is related to IC engines. Actually, this one is a partly mechanical and partly automobile. And here our topic is functioning and constructional details of two-stroke SI engine. And here we already gone through the classifications. The engines are classified in IC and EC, right? The particular topic which we are going to deal with now is related to IC engines, internal combustion engine. If we compare the 4-stroke and 2-stroke engines, there is a huge difference between them. In 4-stroke engines, we have one power stroke for 2 revolutions of crankshaft, which is 360 degrees plus 360 degrees. Revolutions of crankshaft will give one power stroke. And in 2-stroke engines, we have one power stroke for 360 revolution of crankshaft, which is one up, one down of piston, which means one revolution of crankshaft. By this we can say that 2-stroke engines are more reliable for power generation, higher power generation and higher torque generation, because we are getting one power stroke for one revolution of crankshaft. Here we are getting one power stroke for 2 revolutions of crankshaft, right? Here the torque and power is multiplied by 2, right? So here multiplications of torque and power is going to be taking place when we compare 2-stroke engines with 4-stroke engine. So for understanding all this, we have to go through the construction and working of the particular 2-stroke engine. Here is our topic. So construction and working of two-stroke engine. Here we have to go through the constructional details first to understanding working. So the parts in 2-stroke engine are similar as 4-stroke engine. We have piston, we have engine cylinder, and we have crankshaft, we have cylinder block, and we have sleeves. Several things are similar between 4-stroke and 2-stroke, but we don't have any kind of valves in 2-stroke, but we have valves in 4-stroke which operates the inlet and outlet ports. Here in 2-stroke particularly, we don't have any kind of valves. With the movement of piston itself operates ports directly. So here comes the construction details. Here, if I take this one as an engine cylinder, this one as crankcase, here comes the crankcase, and here I have 2 ports. Here is the first port, and here comes the second port. So here comes the second port. So here I have another port. This port particularly called as transfer port, right? So let me draw the diagram of building. Here this one is the cylinder, right? Cylinder. Here comes 2 ports, first port, and here comes the second port. This is the crankcase. Within this we have a crankshaft here, right? We have a crankshaft in crankcase. We have piston here. In this section we have piston here. So here comes the connecting rod. Here this particular one is engine head. Here is fuel injector or spark plug. Here comes an additional port, which is the port is transfer port. So transfer port. So if I take this one as first stroke, during this stroke what happens, the piston moving upwards and I have a deflected structure. I have a deflected structure in piston on piston surface. Here comes the first stroke and here I have a second stroke diagram, and here comes the exhaust port and inlet port. Here comes the crankcase, and here we know here is the crankcase. So in this stroke what happens, the piston is set here. In this stroke what happens, the piston is at BDC, and here comes the port. So here is the transfer port. So in this stroke, the piston reached to top dead center, bottom dead center. In this particular stroke, the piston is at TDC. Right? Let's go to the constructional details of the particular two-stroke engine. This two-stroke engine. So here comes the crankshaft. And this is the crankshaft, and here comes connecting rod. Here comes the connecting rod, and here we have gudgeon pin. Here we have no gudgeon pin. Here a deflector, right? A deflector. Particularly this section is present in two-stroke engines for diverting the charges during the process of scavenging. And here comes the exhaust port. Here comes the exhaust port. Here comes the inlet port, and we have the piston. This one is the piston, and this one is the deflecting section. Here, this one is the piston and diverting section. This one is the engine cylinder. Right? So these are the major parts. Here comes the transfer port. This particular port we cannot find in four-stroke engines. So how this particular the construction and major parts of two-stroke engine has been completed, and what is our next topic? Working. How do this particular two-stroke engine works? So here comes the thing. When the piston traveling from BDC to TDC, what happens? The charges already have admitted in the previous stroke, right? This one is, if I take, this is a cyclic process. If this one I take first stroke, this will be second one, and if I take this one as first, this will be the second one. These are the cyclic process. These are occurring one by one in a cyclic manner. So here comes the second stroke. If I am consider here in this particular video, I am going to consider this particular stroke as a first one. During this stroke, what happens? The piston is traveling to TDC. Means P is direct proportional to T and inverse proportional to T. Here comes the charges which already admitted in the engine cylinder during the previous stroke are going to be compressed, which means here the strokes which are occurring in this particular upper movement of piston or compression plus, look at here the inlet port is open, right? Exhaust port is closed, but inlet port is open, right? Here, look at here, the piston traveling from BDC to TDC, which result in volume increase in this particular section, right? In this particular section, volume is increasing, which means volume increasing means pressure reducing. Pressure reducing means here negative pressure creates, which sucks air or air fuel mixture through a carburetor or filter from atmosphere, right? From a carburetor. If I take this one as a SI engine, so here intake, right? When the piston reaches to TDC, theoretically we have a spark in SI engine or fuel injected, fuel is injected in CA engines, right? At this time, what happens? Ignition takes place, and we have expansion, or sorry, not expansion, ignition. So ignition, and within this particular stroke, within one movement of piston from BDC to TDC, we have compression stroke, intake stroke, and ignition stroke, right? Here comes the thing. In the next stroke, the piston after ignition, what happens? The piston, travels from TDC to BDC. The burnt flue gases with high pressure pushes the piston down, and which results the rotation of crankshaft, right? Which results the crankshaft rotation. And here comes the thing. Here, look at here. We have expansion stroke. Expansion stroke. So with this expansion, the piston moved from TDC to BDC. So what happens? Here comes the thing. Here, look at here, the bottom portion. Here is the inlet port. About this one is the inlet port, and this one is the exhaust port. Here, exhaust port opened by the piston, and inlet ports remains closed. With the movement of piston, what happens? The piston surface, this left side surface, closes the piston, closes the inlet port, and opens the exhaust port. What happens? Here, the volume is reduced. Again, here volume is reduced, which means increase in pressure in this particular crankcase section. Here, during upward movement of piston, what happens? The charges are admitted in this particular crankcase section are going to be compressed, right? Here volume reduced, and which means pressure increase. Within this crankcase section, the pre-admitted charges are going to be compressed, which result in flow of that particular charges into the engine cylinder through this transfer port, right? Here is the escape port. Through this escape port, transfer port, which we can call as transfer port, so through which inlet, so charges are going to be entered into the engine cylinder, and which pushes the flue gases away from the so here the opened exhaust port. Through this exhaust port, the charges are going to push the flue gases away from the engine cylinder via this exhaust port. So here comes the process, which is called the pushing away the flue gases by the charges, and this particular process we call it as scavenging. So scavenging stroke. So here comes the exhaust. So here we have compression, intake, and ignition at a time, and here we have expansion, scavenging, and exhaust, right? Within the one up and one down movement of piston, we have all these strokes. We have intake, compress, expansion, and exhaust. Additionally, we have scavenging and ignition, right? So that's why these engines are most reliable for higher power generation and higher torque. Actually, we can find these kind of engines in bikes. The youth favorite bike, which is RX100, and the old model Suzuki bikes also equipped with this kind of engines. And presently, we are not having any bikes which comes with this particular SI engine, because these engines are during the scavenging process. What happens? Some charges are going to be escaped from engine cylinder along with the flue gases. So here these are not that much friendly engines for environment as compared with four-stroke engine. These engines are creating higher pollution levels in the environment. So these kind of engines are going to be avoided in the coming future. Maybe by the government they may be banned in the next coming days. So this is about two-stroke engine. Up to here, the particulars which comes under the construction and working of two-stroke engine has been completed. In the next upcoming videos, we'll go through the next topics which are related to IC engines and automobile. So Thank you for watching. Do subscribe to the AMG World. Click on the bell icon. Thank you for watching.